Receptor binding assay. The receptor binding assay, or RBA, is divided into three major steps. First is the preparation of reagents and standards. Second is the RBA proper. And the last step is the analysis using graph pad prism. But before we proceed, it is also important to become familiar with some terminologies. Some of these were already mentioned in the previous chapters. Ligand is a substance, usually a small molecule, that forms a complex with a biomolecule to serve a biological purpose. For PSP-RBA, it is the saxitoxin molecule. Radioligand is a radioactive biochemical substance, in particular a ligand, that is used for diagnosis or for research-oriented study of the receptor systems of the body. For PSP-RBA, it is the tritium-labeled saxitoxin. Receptor or synaptosome, a substance, usually a protein, that specifically binds a certain compound, a ligand. When we say stock or stock concentration, it pertains to the solution with its original concentration or the concentration at which the solution is being stored for longer periods of time. When we say working solution or working concentration, it pertains to the solution or concentration of the solution before RBA plating, or the actual concentration to be used in the assay. When we say in-assay concentration, it pertains to the concentration of each reagent during the reaction, assay, or plating. For example, the stock of membrane in every 2 milliliters of cryovial has a stock concentration of 8 milligram protein per milliliter. Then, we were asked to prepare 20 milliliters of working solution with a concentration of 1 milligram per milliliter. Therefore, you have to pipette 17.5 milliliters of buffer into a centrifuge tube and add 2.5 milliliters of stock membrane solution. You now have a working membrane solution with a concentration of 1 milligram per milliliter. Suppose during the assay, you have to pipette 105 microliters of membrane to react with the sample and tracer, making a final volume of 210 microliters. The in-assay concentration of your membrane will then be 0.5 milligram per milliliter. With these, we are now ready to prepare the reagent solutions. For the preparation of reagents and standards, 6 reagents should be prepared, namely 1. The assay buffer. 2. Samples or toxin extracts. 3. Toxin standard. For paralytic shellfish poisoning toxin, it is saxitoxin. 4. QC check. 5. Tracer or the tritium-labeled saxitoxin. And lastly, 6. Synaptosome or membrane. Step 1. Preparation of reagents and standards. For this step, you'll need the following reagents, chemicals, materials, and equipment. 1. Distilled water. 2. 3-morpholino-propane sulfonic acid, or MOPS. 3. Choline chloride. 4. Toxin extracts. 5. Saxitoxin standard. 6. Tracer or tritium-labeled saxitoxin. 7. Membrane preparation. 8. Spatula. 9. Reagent reservoir. 10. Beakers. 11. Magnetic stirrer. 12. Volumetric flasks. 13. Graduated cylinder. 14. Titer tubes or dilution tubes. 15. Centrifuge tubes. 16. Single and multi-channel pipetors. 17. Stir plate. 18. pH meter. And 19. A top loading balance. A. Assay buffer. Assay buffer is the 100 nanomolar MOPS choline chloride buffer at pH 7.4. To prepare the assay buffer, the 100 nanomolar MOPS choline chloride at pH 7.4 weigh out 20.9 grams of 3-morpholinopropane sulfonic acid, also known as MOPS, and 13.96 grams of choline chloride. Then dissolve the chemicals in 900 milliliters of distilled water. Adjust pH of solution to 7.4 with 0.1 molar sodium hydroxide solution while stirring. Dilute volumetrically to a final volume of 1 liter with distilled water. Then store at 4 degrees Celsius. B. Sample or toxin extracts. It is important that the working sample solutions should be prepared on the day of the assay. This is to avoid any biochemical transformation of saxitoxin into different analogs. Prepare 1 in 10, 1 in 50, and 1 in 200 dilutions of the toxin extract with assay buffer. Dilutions must be based on the approximate concentration of the toxin in the sample. Since each concentration is assayed in triplicates and each well requires 35 microliters, you should have a minimum of 105 microliters of working toxin extract solution. To be safe, we will prepare at least 250 microliters of each dilution. And to avoid errors due to pipetting of small quantities, prepare the solutions by serial dilution. Prepare 3 tubes and label the tubes as A, B, and C respectively. Tube A will be the 1 in 10, B the 1 in 50, and C the 1 in 200. Pipette 360 microliters of buffer into tube A, 400 microliters into tube B, and 375 microliters into tube C. Pipette 40 microliters of extract into tube A. Perform pipette in and out 3 times to ensure that all the actives will be in the solution. Then vortex the tube. To prepare the 1 in 50 dilution, pipette 100 microliters of 1 in 10 dilution or solution in tube A into tube B. Rinse the pipette tips and vortex. For 1 in 200, pipette 125 microliters of 1 in 50 dilution into tube C. Rinse the tips and vortex. Keep aside until plating. C. Toxin standards. The unlabeled saxitoxin reference standard is provided at a concentration of 268.8 micromolar with 100 microgram per milliliter diluted in hydrochloric acid. A bulk serial dilution for the standard curve is made up from this reference solution in advance and stored at 4 degrees Celsius for up to 1 month. The use of bulk reference dilutions minimizes the pipetting needed for setting up an assay routinely and improves day-to-day repeatability. To make up the standard curve, Refer to the table of saxitoxin serial dilutions at the bottom of the screen. Prepare the tubes and label from A to G and blank. Pipette appropriate volume of 0.003 molar hydrochloric acid into the tubes. For tube A, the starting solution would be the stock saxitoxin standard from NRC Canada. Make sure to vortex the solution before pipetting and to rinse the tips. Use new tips for every concentration. These standard solutions are then aliquoted in 120 microliter portions and placed in microcentrifuge tubes. Each tube corresponds to one assay plate. It would be better to prepare one set with each dilution to prevent thawing of the whole batch every assay. D. Quality control check. The quality control or QC check confirms day-to-day performance of the assay. This is a reference standard containing 1.8 times 10 to the negative 8 molar saxitoxin standard, equivalent to 3.0 times 10 to the negative 9 molar saxitoxin in assay. This is usually prepared in advance in 0.003 m hydrochloric acid and kept frozen at negative 80 degrees Celsius in 0.5 milliliter to 1 milliliter aliquots for long-term storage. Aliquots should be thawed and stored at 4 degrees Celsius for routine use. Similar to the bulk toxin standards, it is stable up to 1 month. Aliquots of 200 microliters may be prepared and an aliquot may be packed together with the toxin standard set. Even the concentration of tube E from toxin standard is similar with the QC check. Do not use tube E as the QC. This is to avoid errors due to serial dilutions that will influence the accuracy of your assay. The QC is being prepared directly from the reference standard and not by serial dilution. Based on your computation and desired volume of QC to be prepared, pipette appropriate amount of 0.003 molar hydrochloric acid into a 15 ml. Pipette the computed volume of reference standard into the 15 ml tube and vortex. Prepare the tither tube and label with QC and the date prepared. Pipette 200 microliters into each tither tubes. Pack the tubes together with the set of toxin standards. E. Preparation of the tritium-labeled saxitoxin solution. Upon receipt of the tracer, check the integrity of the container and note the specifications of the product. The stock tritium-labeled saxitoxin is usually provided with the following specifications: 50 microcuries per ampole, 24 curies per millimole, 0.1 microcurie per milliliter, which is equivalent to 4.17 micromolar. For the assay, prepare a 15 nanomolar working solution of tritium-labeled saxitoxin for each assay fresh daily. This will provide a 2.5 nanomolar final concentration in microplate wells. For the procedure, pipette 3.86 milliliters of assay buffer into 15 milliliter tube with cover, and pipette 14 microliters of stock tritium labeled. Note that the amount of tritium labeled saxitoxin added may vary according to its specific activity. Measure total counts of each working solution prior to running an assay by taking 35 microliters of the tritium-labeled saxitoxin working solution to a liquid cyantillation vial with 4 ml scintillant and count using a liquid scintillation counting. A volume of 35 microliters of the tritium-labeled saxitoxin working solution should contain 27,650 disintegrations per minute, or DPM. Depending on the efficiency of the scintillation counter used, the corresponding counts per minute, or CPM, will vary, but should be consistent day to day and within 15% of the expected value. F. Membrane or synaptosome. It is important to note that the preparation of the membrane solution should be performed over ice. This is to prevent denaturation of protein. Proteins are denatured upon exposure to heat and thus make the receptors inactive. This may lead to variability of the results. For the procedure, thaw rat brain membrane aliquot. Dilute membrane preparation with ice-cold assay buffer to yield a working stock with a protein concentration of 1.0 milligram per milliliter. This will be diluted further in the assay plate to 0.5 milligrams per milliliter in well concentration. Note that based on the result of protein assay, the volume needed to prepare the 1 milligram per milliliter membrane may vary. To prepare 1 milligram per milliliter stock membrane solution from an aliquot of 10 milligram per milliliter, pipette 18 milliliters of ice-cold assay buffer into a 50 milliliter tube with cover. Vortex the membrane aliquot and pipette 2 milliliters into the 50 milliliter tube with buffer. Vortex. Then keep the solution on ice until plating. Step 2. RBA proper. Prepare all the reagents and materials ready. Keep the reagents inside an ice bucket to maintain low temperature. Check the integrity of the 96 well microtiter filter plate with FB glass fiber filter with 0.65 micron pore size. For ease of analysis, it is convenient to use a plate layout which maximizes the number of samples and reference standards that can be analyzed on one plate. Pour some ice-cold assay buffer into a reagent reservoir and start plating using a multi-channel pipettor. Pipette 35 microliters of assay buffer into each well. Pipette 35 microliters of saxitoxin standard, quality control check, or sample extract into the wells. Pour the tracer solution into a reagent reservoir and pipette 35 microliters into each well. Vortex the membrane preparation and pour into a reagent reservoir. Pipette 105 microliters into each well. Make sure to pipette in and out thrice in every pipetting to ensure even distribution of membrane in solution. Incubate the plate in 1 hour at 4 degrees Celsius. After the 1 hour incubation, place 96 well plate on the multi-screen vacuum manifold. Fill empty wells with 200 microliters of assay buffer to ensure even filtration across the plate.